Hey guys, Mr. Newton today. Today's lesson is going to be on some of the basics of physics, which is called position. Distance, displacement, scalar, and vector. Now, maybe those are all new words for you. Maybe you've heard of some of those words like distance before, but we're going to make them a whole lot more complicated than they've ever been, which will be fantastic because you should walk away from this video just a little bit smarter. All right, so let me show you something. We're going to talk about the concept of position. This is a big deal in physics. Position, we use the symbol X for position. So if you see an X anyways, it means a position. Now, what is a position? Well, a position is pretty much defined as a place on a coordinate plane. You guys have been using these coordinate planes your whole life. Well, maybe not your whole life, but you got your y-axis, right? You got your x-axis right here. And then most of the time in physics, time goes on your x-axis, which is why I only drew the positive end of it because, time doesn't go negative, or at least we don't know that it does yet. And if you can do that, if you can make time go negative, that might be pretty awesome, and you will probably be able to do some pretty crazy, amazing things, or maybe we'll just keep watching movies and that's the only time time goes negative. So anyways, right here we've got the idea of position. So a position is a place with reference to a start point. And so if I put a position right here, boom, that is a position. That position has a x coordinate, has a y coordinate, you see? So your x, y, and your simple linear equations, those were positions, right? You've got these little x, y coordinates, and that is a position, okay? This down here is a position, right? And so let's say that I was actually charting something right here, and I went like this, boom, boom, okay? That would have shown me that, let's say right here that my y is distance, okay? And my x is time, of course. Let's say this is 1, 2, 3, right? And then -1, -2, -3. So here's -1, and I've got 1 right there. What is this telling me? Maybe my time is 1, 2, 3, 4, right? What is this telling me? Well, that's telling me that I moved forward maybe this is 1 meter, and then I actually went backwards 2 meters because I went back to the start point and then back behind the start point another meter. So position, what we see from position is that direction matters, and on the graph you can see that direction matters. I need to know if I'm going forward or backward because it changes where that point is going to go. So in physics, anytime direction matters, we call that a vector. Okay, so a position is a vector quantity. And so we talk about vectors all the time. So a vector is always basically an arrow. So boom, that's a vector, okay? That means it went that way. Okay, boom, if I do that, it went that way. Okay, boom, it went that way. So I'm showing you a direction and then, indicating motion. And so vectors always have direction, okay? Now you can have measurements that don't have direction. Like for example, if I'm driving my car and I look at my speedometer and it shows me that I'm going 25 miles per hour, it doesn't tell me, it doesn't care if that's north or south, or if I was going 25 miles per hour north and then I started going 25 miles per hour south, if direction mattered, those would cancel each other out. And so in a speedometer, direction does not matter. It's just the number, the value, the 25 miles per hour is what matters. So if direction does not matter, direction doesn't matter, we call that scalar, okay? So S-C-A-L-A-R, scalar, right? So sorry about the handwriting there. Scalar. Hopefully you guys can figure that out. So vector, direction matters. Scalar, direction does not matter. Two of the best examples for that are distance versus displacement. distance versus displacement, okay? So distance is scalar, okay? And so distance is just how far, right? And displacement is vector. And so displacement is how far from the start, you see. How far from the start, okay? So for example, if I look up here at my let's say that I look at this position right here, right? This position right here. Well, if I take into distance, look, I went 1 meter and then I went back 1 meter. So my distance is actually 2 meters. But if I look at my displacement, how far from the start, my displacement is 0. Okay? Or imagine that you're running around a circular track, right? If you go 100 meters, okay, that's your distance. You ran 100 meters all the way around that track. That's your distance. But your displacement, once again, is 0 because you ended up right back where you started. So in displacement, direction matters because when you went around the track, you went out and then you came back. And so it canceled out. And so displacement is distance, but where direction is taken into account. And distance is just straight up distance. It doesn't matter if you get back to the start point. It's just your total distance. Okay. So those are the main concepts of scalar versus vector. Okay. And we've got our two examples of distance versus displacement. One is scalar, one is vector. Distance is scalar, displacement is vector because the direction actually matters. And position is also a vector because its direction matters, and you would plot that position differently on the graph given a different direction, and the graph will show that. So those are two major concepts in physics, scalar and vector, and we also learn about position. And position is always going to be something in reference to a coordinate system.